Hello, everybody. Today we are doing an interview about physics. Can you tell us your name, sir, and what your project is about?
My name is Daniel Valadez, and what I want to discuss to you about is my project that I did recently, which I'll call it the discovery of electrons. And the way I thought of this project was it was an idea to find out what electrons even do. And to even get started with that, I had to find out what mechanisms I had to use. And turns out there was this scientist named William Crookes that created this mechanism called a cathode ray tube. It's a device where it just shoots out beams of just pure electrons. And what it requires is all you need is high voltage that's connecting inside the tube of a plus cathode and a minus anode. And it shoots out a straight line of beams, not going up, not going down, just straight beams.
And what were you guys trying to do or find?
What we're trying to do is see how electrons react, pretty much. And I will say this: we know how electricity worked. We kind of know the idea of electrons, but we don't grasp about the idea of how electrons behave and nature in general. So what we're trying to do is see how electrons react when we put in some certain experiments with it, such as does it go up and down when we put a north pole in it, or does it stop? Does it not show beams if we put like some form of material in it and such? And we did a couple of try errors with the electrons.
That is great to hear, Mr. Daniel. Where did the project or the experiment occur exactly?
It occurred in Campbell University. It's located in the United Kingdom. Yeah, and that's where I teach. I teach my students. I'm a professor there at Campbell University as well. I teach fellow students about just basics physics stuff to get started on their careers. And sometimes teach some lectures about classical physics and such.
That is great. What other significant events were happening around the world at that time?
What I heard is that there was an X-ray that was invented. I can't think of the name off the top of my head, but I remember it happened 2 years ago where an X-ray was invented, and that was a help of using a cathode ray tube. And what I find interesting and cool and also fascinating is that this device can actually see through your like flesh bone. I mean, not flesh bone, your flesh skin. Like it can see your bone and it can see like what's inside of it, how what it has, what can it do, and such. And what I like about it is that this cathode ray tube is a reason why X-rays exist. And when I think about it, cathode ray tubes are going to shape the way we see electricity in general. And 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 thanks to William Crookes, it helped me find out how electrons work. Even though what I'm doing is way different from X-rays, the similarity between the two is that it shoots electron beams, and it does it for a reason. X-rays, not sure how it can see through, but for me, when I did the discovery of electrons that beams up or downwards, I discover its natural response and reacts when I do certain mechanism with it.
And who else was involved in the project?
Who else was involved is they rather not have their names spilled out in public. I'll just say they're just my fellow scientists, researchers, and they are proud of what they did and what they have accomplished. And I am proud of them because they helped me use this cathode ray tube to s- to see how electronics flow and how they work.
And what exactly was your role in the project?
My role in the project, it was just to see how electrons really work and how I even discovered electrons existed. And to start with, we did a magnetic field test. We see how it was reacting when we use certain repulse and attract. Like for example, we have this. Let's use this pencil as a magnetic pole. Correct. This is the north. This is south. The way it works, north goes up, does a little bit of curve, down a little bit of curve, and then goes right back to south. South is the input, north is the output. You can imagine this as a tube. This is water. Let's imagine this as a beam, electrons. When I put my south, my north, when I put my north right about here, my pencil right here, this is my magnetic north pole. You can imagine that this water is going downwards. It's kind of hard to show you, but you can imagine it. That when my north pole is going here, the water goes down. Now, if I flip it, this is now my south, it goes up. The water goes up. When I put my magnetic pole south, close to the electric beam, it just shoots straight up. It's obviously hard to just visualize, show you exactly how it does it because this water's pretty hard to use when it comes to electron demonstration, but you get the idea. It goes up when it's south, it goes down when it's north. And that helps me um, discovered how electrons work. And it turns out that electrons have a negative charge with them.
Hmm, that is very interesting. And what impact did your project have on the physics community?
Well, it impacted several things, several um, projects, programs. It almost impacted the whole world, honestly, thanks to my invention. But not invention, my discovery of electrons. It helped scientists see the way electrons move, and it helps them realize that atoms are not just indivisible, meaning that you have an electron that's also have since electrons are a negative charge, there's another particle that's positive, and that's the way to balance out the atom, I believe. And honestly, when I when the electrons are discovered, they're they have created new science I can call modern science, where now they understand how electrons will work, how they behave in natural science, and it really just shaped the world of physics in general. It will help in future generations about how we could use electricity more fluently and more efficiently.
That is very interesting, Mr. Daniels. Thank you for your time today. It was glad to have
Uh,
you here.
Thank you, sir. Thank you.